Hello, and welcome to Sleepy Science Story. This is your time to slow down, to let the world soften at the edges, and to drift somewhere quieter for a while. Tonight, we're curling up beside one of the strangest, most wonderful mysteries the universe has ever whispered into the dark: black holes. They're not villains or voids, really more like cosmic lullabies written in the language of gravity and silence. So, get cozy. Let your thoughts float like stardust in a slow spiral. And if you happen to doze off somewhere between Fact 7 and Fact 73, well, I'll consider that a compliment. Black holes don't begin with a bang. They begin quietly, so quietly in fact that no one ever hears them arrive. They slip into the story when a star grows tired, when the glow it once gave so freely begins to flicker. That flicker isn't a death exactly, it's more like a sigh, a slow folding inward, a retreat. And in that gentle withdrawal, something extraordinary begins. The star collapses, its outer layers drifting off like the petals of a burnt-out flower, while its heart contracts with an almost embarrassed intensity. The space around it, once content to simply be, begins to bend. It's subtle at first, like the air shimmering above a warm road, but then it deepens, warps, curves in on itself, until the very fabric of space becomes a funnel, not loud or wild, but like a whisper leaning just out of reach. There is a boundary, invisible and patient, where light can no longer escape. It doesn't flare or blink. There are no warnings, no trumpets, only the quiet hush of something that has passed beyond the reach of time as we know it. This boundary is called the event horizon. It is not a wall or a door, but more like a final chance, the last breath of light before it vanishes from sight forever. Anything that crosses it doesn't scream or spin. It just goes silent, as if falling asleep mid-sentence. From the outside, time seems to slow near this threshold. A falling object appears to hover there, stretched and frozen, like a feather paused in the air. But inside, time is another thing entirely. It flows inward, downward, toward a center that can't be seen, and may not even exist in the way we understand places to exist. What lies beyond the horizon is mystery, wrapped in gravity. Not danger in the ordinary sense, but something purer, a sort of devotion to silence, a concentration of mass so profound that it becomes a kind of absence. A black hole isn't black because it is empty. It is black because it is full of something that light cannot leave. It does not glow. It does not reflect, it simply is. A stillness that doesn't end, a shadow without a source. And yet, for all their seriousness, black holes are not grim. They are poetic. They bend the rules, rewrite them, fold them into themselves and vanish them completely. They are the dreamers of the cosmos. Strange, beautiful things that began with a flicker and ended with a gravity so strong it erased its own story. But perhaps not entirely, because here we are, talking about them, wondering, whispering back to the whisper at the edge of light. Every star lives a story, and like every story it has a beginning, a middle, and an end. Most stars end with a gentle sigh, fading slowly into cool embers, casting their last warmth into the darkness, before settling into a quiet retirement as a white dwarf. But some stars are far too heavy for such a soft farewell. They burn hotter, shine brighter, and live faster than their smaller cousins. They rush through their lifespans like dreamers sprinting through a meadow at twilight, knowing the sun is already setting. Their cores build heavier and heavier elements, layering them like a secret being folded over and over again. The pressure mounts, gravity whispers more insistently, and one day the balance tips. When that tipping point arrives, it is not a slow dimming but a sudden surrender. The outer layers are thrown outward in a spectacular explosion, a supernova that can briefly outshine an entire galaxy. To any watching eye, it might look like a final act of defiance, a dazzling flash before nothingness. But the real drama is hidden at the core, where the star's heart has begun to fold in on itself, shrinking, tightening, becoming impossibly dense. Gravity has won, but it is not cruel. It is patient and absolute. The matter of the star, unable to hold itself up any longer, collapses inward with astonishing speed. This collapse is not an ending in the way we usually think of endings. It is more like the moment you slip under the surface of water and the world above becomes muffled and distant. The star's mass condenses beyond anything we can imagine, beyond any surface we can touch. The atoms themselves are crushed, their identities lost, their individual dances merged into a single overwhelming gravitational pull. Out of this quiet catastrophe, a black hole is born. There is no sound, no announcement, just a new presence in the cosmos, silent and invisible except for the way it bends the space around it. These heavy stars, the ones that sleep too heavily, are the architects of these strange objects. Without them, there would be no black holes, no gravitational wells drawing light itself inward. They are not punished for their size, they are transformed by it. And somewhere in that transformation lies a kind of cosmic poetry. A bright life burning fast, a spectacular release of energy, and then a retreat into a darkness so complete it hides its own heartbeat. When we look up at the night sky, every brilliant point of light is telling its own quiet future. Some will fade softly, some will explode, a few will fold themselves into a darkness deeper than sleep. And from that darkness, new stories, like this one, will begin. Gravity is the quiet force that threads the universe together. It is the invisible hand that keeps planets in their paths and stars in their beat, clusters. Most of the time it feels gentle, like a soft pull you hardly notice. You feel it as you sit or lie down now, a faint weight holding you close to the earth. But out among the stars, gravity can grow so strong that it ceases to feel like a gentle nudge and becomes a slow, endless embrace. Black holes are the places where that embrace has tightened beyond anything else we know. They are not angry or greedy. They are simply the deepest expressions of gravity, so dense that even light cannot slip from their arms. Imagine floating toward one of these objects. From far away, it is not threatening at all. Space is quiet and still, and the black hole is almost invisible, marked only by the glow of matter circling it. At first you might feel nothing, the same weightlessness you feel drifting anywhere else in space. The pull is there but subtle. It's only as you move closer that the force begins to deepen. Time stretches, space curves. The light around you starts to bend, tracing strange arcs and looping paths. The deeper you go, the stronger the pull becomes, until it feels less like movement and more like being held. Not a tug, not a jerk, but an unending hug, drawing you inward with patient certainty. Gravity in this form is not cruel. It is complete. It asks nothing and gives nothing except the irresistible pull of mass on mass. A black hole is gravity without limits. Where a star or a planet can balance its own weight with outward pressure, a black hole has no such counterforce left. Everything inside it has collapsed into a single point, or something so close to a point that our physics can barely describe it. Around this point the event horizon forms, the invisible boundary where escape becomes impossible. It is not a wall or a trap, it is simply the place where the hug becomes forever. Thinking of gravity this way can make black holes feel less like cosmic predators and more like cosmic homes. They are places where matter goes to rest, to be held in the tightest possible way. They are not monsters lurking in space, but the natural conclusion of a force that has been at work since the first atoms drifted through the newborn universe. In a sense, gravity is the oldest lullaby. It pulls everything together, shaping stars, shaping galaxies, shaping you. And black holes are the final note of that lullaby, a slow, endless embrace, humming quietly at the edge of the visible. Despite the dramatic name, the event horizon is not a sudden or violent thing. It does not mark an explosion or a collision. There is no noise, no light, no sudden flicker in the sky. It is not an event in the way we usually think of one. Instead, it is more like a threshold that simply exists, a quiet line in the dark where the rules begin to change. You could cross it without ever knowing. There would be no shimmer in the air, no tremble underfoot. One moment you would be outside, and the next you would be beyond. And yet that small shift would change everything. The event horizon is the point where escape becomes impossible. Not because you are being pulled, but because every path forward now curves inward. Light, which normally travels in straight lines, can no longer find its way out. Even if you moved as fast as light itself, you would not make it back across. It is like reaching the edge of a hill so steep that every step forward is also a step downward, and the slope only steepens as you continue. You are not dragged. You are not pushed. You are simply surrounded by a geometry that leads you inward, no matter what you do. From the outside, things look strange near this invisible border. Time seems to slow for anything falling in. A spacecraft or even a speck of dust might appear to pause there, hovering in place forever, stretched by gravity, fading gradually from sight. But that is only a trick of perspective. From the point of view of the falling object, everything continues smoothly. No pause, no warning, just a passage through a boundary that cannot be seen or touched, only described by the math that predicts it. In a way, the event horizon is a kindness. It is a veil drawn around something we are not yet ready to understand. It hides the singularity, that mysterious center of a black hole, where our laws of physics begin to unravel. The horizon protects us from having to stare directly into a place where time and space twist into something else entirely. It allows the black hole to exist quietly, not flaunting its secrets but keeping them tucked behind a curtain that only the most determined things can pass through. Thinking about the event horizon can be like imagining a moment where change becomes irreversible. Not loud, not dramatic, but final all the same. It is the soft click of a door that closes behind you. A breath you did not realize was your last before stepping into something new. Not an event in itself, but the edge of one. A gentle, quiet line that marks the beginning of everything else that happens next, hidden from view, held in silence. Of all the strange things that black holes can do, perhaps the most quietly unsettling is the one that sounds the silliest: spaghettification. It does not sound like science. It sounds like something you might read on the side of a pasta box. But in the realm of black holes, this whimsical word describes a process that is anything but playful. It is the result of tidal forces stretched to their limits, gravity showing off just how precise and unforgiving it can be when there is nothing left to balance it. Imagine, for a moment, drifting slowly toward a black hole. You are peaceful, unbothered, simply floating closer and closer. But something strange begins to happen. The parts of you that are nearer to the black hole begin to fall faster than the parts of you that are farther away. The difference is subtle at first. A soft tension, like the gentle pull of water as a tide rolls in. But as you drift closer, the difference grows. Your feet are being pulled more strongly than your head, or your head more than your feet. depending on which way you are facing. Gravity does not act equally on all parts of you. It pulls harder on the near, weaker on the far, and this unevenness creates stretch. If the black hole is small, this stretching becomes noticeable very quickly. In the final moments before you cross the event horizon, the forces grow intense enough to lengthen you into a thin, narrow strand. Not crushed, not smashed, but elongated, like a noodle. The word may be funny, but the process is quiet and absolute. Gravity does not rush, it simply continues, increasing its hold inch by inch until your shape is not quite your own anymore. In larger black holes, the stretching happens farther in and more gently. You might not notice it until long after you have crossed the event horizon. Some physicists even suggest that in a supermassive black hole, you could pass the point of no return without feeling anything at all. It is only deeper inside, where the singularity waits, that the full force of the stretching would take hold. By then, you are already too far to turn back. The beauty of spaghettification is not in its name, but in what it tells us about gravity. It reminds us that space is not empty. It is shaped and curved and pulled. It responds to mass in ways that affect everything, even your body, even your atoms. In everyday life, these tidal differences are so small we do not notice them. The ocean moves with them, but we do not. But in the arms of a black hole, gravity does not whisper, it defines. And it shapes you completely, stretching you into a line that slowly and silently disappears into the dark. At first glance, a black hole is thought to be pure darkness, a shadow against the sky that swallows everything and gives nothing back. It is called black because nothing can escape it, not even the light we rely on to see the world. But the truth, as it often is in science, is more curious and more beautiful. A black hole is not completely black. It glows just a little. It hums with a quiet presence that is not from within but from around it. And sometimes, under the right conditions, it begins to evaporate. This quiet leaking of light is known as Hawking radiation. It does not come from the black hole itself, not exactly. It comes from the space just outside its edge. In the quantum world, even empty space is not truly empty. It fizzes with energy, particles appearing and disappearing so quickly we would never notice. These particles always come in pairs, opposites created together. Normally, they find each other again and vanish just as quickly. But near the edge of a black hole, something unusual can happen. One particle may fall in while the other escapes. The black hole has taken one in but cannot call the other back, and so the escaped particle becomes real. It floats off into space, carrying energy with it. From far away, it looks as though the black hole is glowing. Slowly, softly, it is radiating warmth. Not a warm light like the sun, but a faint whisper of energy, a flicker so small it would take more time than the age of the universe to notice. But over unthinkable lengths of time, this trickle of particles adds up. The black hole begins to lose mass. It begins to shrink. Very slowly, it begins to disappear. Stephen Hawking proposed this idea, and it changed the way we think about black holes. Before that, they seemed like final destinations, absolute ends, places where information was lost forever. But with this glow, faint though it may be, came a kind of return. The black hole is not silent after all. It tells us a story, in the faintest of voices, over billions upon billions of years. This radiation is not enough to brighten the sky. You would not see it with your eyes or feel it on your skin. It is quiet beyond measure. But it matters. It tells us that black holes are not eternal. They are long-lived, certainly. But they, too, change with time. They, too, have a journey. They begin with collapse and end with a fade, not with a bang, but with a breath. A soft surrender back into the space they once bent so deeply. So black holes are not so black. In the end, they shimmer, they whisper. They leave behind the faintest trail of light, not enough to guide a traveler, but just enough to say they were here. There is something deeply soothing about the idea that some black holes can sing, not with voices, not with melodies, but with vibrations so low, so slow, that they become more like the heartbeat of space itself. We cannot hear these songs with our ears. They do not ripple through the air. They move through space-time, stretching and squeezing it ever so gently, like the soft rise and fall of breath in a sleeping chest. When two black holes spiral around each other, they dance. It is not a fast dance. It is patient and quiet, unfolding over eons. With every orbit, they send out waves. Not waves of water or light, but waves of gravity. These are gravitational waves, ripples in the very fabric of the universe, moving outward like circles spreading across a still pond. Except this pond is space-time, and these ripples travel at the speed of light. The idea that space can ripple was once just a theory, a beautiful thought scribbled on paper, elegant and impossible to test. But in recent years, we began to listen. We built instruments so sensitive they could detect distortions smaller than the width of a proton. We pointed them toward the stars, held our breath, and waited. And one day, we heard something. Not a sound in the usual sense, but a pattern, a chirp, a signature, the final echoes of two black holes merging into one. The wave that reached us had traveled for over 1 billion years. By the time it touched our detectors, it had stretched across galaxies, drifting quietly through the vast emptiness of space. It was gentle and brief, a flutter, a sigh, a momentary note from a distant cosmic duet, and yet it told us so much. It confirmed that black holes do not live in silence. They speak through gravity. They hum with their own strange music. If we could somehow convert those waves into audible sound, we would not hear sharp tones or sudden crashes. We would hear the slow, deep pulse of something enormous. A note so low it could take hours to complete a single cycle. A kind of cosmic drumbeat that lingers at the edge of perception. These are not songs in the way birds sing or violins play. They are songs in the way tectonic plates shift, slow, deliberate, powerful. Thinking of black holes in this way softens them. They are not just cold objects swallowing light. They are participants in a kind of celestial rhythm, a choreography that plays out across the universe in perfect silence. And even though we cannot hear them in the way we hear wind or water, the fact that we can feel their song even faintly reminds us that nothing in the universe is truly still. Even in the quiet, something is always moving. Something is always singing. Long before galaxies bloomed and stars settled into the rhythms we know today, the universe was young and wild. It pulsed with heat and energy, a dense fog of particles swirling in all directions. In those early moments, everything was close together. Time had barely stretched its arms. Space had only just begun to breathe. It was during this youthful, chaotic chapter that something strange may have happened. Something small, quiet, and easy to miss. Tiny black holes might have appeared, scattered like sparks across the fabric of the newborn universe. These are known as primordial black holes. They are not formed from collapsing stars, because at that time there were no stars yet to collapse. Instead, they might have formed from pockets of energy slightly denser than the rest. Little wrinkles in the glowing soup of existence, pressed so tightly together that gravity took over before anything else had. A chance. They could have been as small as mountains or as heavy as planets, packed into spaces smaller than a grain of dust. No light, no sound, just quiet weight floating through the glow. If these tiny black holes were born in those first fleeting moments, some of them might still be out there, silent, wandering, slipping between the stars like forgotten seeds waiting to be found. They do not glow, they do not bend light in dramatic ways. Most would be too small to be noticed, even with our most careful tools, but they might be gently tugging on things, disturbing the paths of planets, ever so slightly, adding a little extra gravity where none is expected. Some scientists wonder if these miniature black holes could explain mysteries we have yet to solve. The puzzle of dark matter, for instance, the invisible stuff that holds galaxies together and outweighs the stars themselves. Maybe, just maybe, some of that mass comes from ancient black holes, still drifting through the dark like quiet passengers in a ship with no lights. Of course, we have not seen these primordial black holes. We do not even know if they truly exist, but the idea is like a lullaby from the beginning of time. It reminds us that the universe has layers we cannot yet touch. It whispers that not everything begins with a star or ends with a flash. Some things begin with a fold, a ripple, a pause in the brightness. And if they are still out there, those baby black holes are not lost. They are part of the same story we now find ourselves in. A story that stretches from the first flickers of time to the quiet thoughts you are having now, perhaps just before sleep. Not all black holes are giants. Some may be small enough to fit inside a whisper, and some whispers never go away. They only drift, softly and slowly, waiting to be heard. At the heart of almost every galaxy, there waits a quiet giant, not a star, not a planet, not something you can see with a telescope the way you might spot Saturn's rings or a comet's tail. What rests at the center is much heavier, much older, and far more patient. A supermassive black hole. These are not the result of a single star collapsing. They are born through more complex means. Layer by layer, moment by moment, mass gathers and settles and folds inward, until what remains is a weight so deep that it bends the galaxy around it. The one in the center of our own Milky Way is called Sagittarius A*. It sits calmly, about 26,000 light-years away, surrounded by swirls of gas and dust and the gentle orbits of nearby stars. From this distance it poses no threat. It is not consuming everything in its path or tearing stars apart on a regular basis. In fact, it is quiet. Still. A dark weight in a shining sky, content simply to be. It is strange to think of something so powerful as peaceful. But black holes are not wild things. They are defined by order, by gravity doing what it does best, which is to hold. And supermassive black holes do just that. They hold entire galaxies together. Like the weight at the center of a spinning mobile, they give structure to the stars that orbit around them. Without that central anchor, the galaxy might come undone. The spiral arms might loosen and drift away, but with it, the stars find their place. We used to think of black holes as destroyers, as dark beasts consuming all light and matter around them, but in time we learned that they can also be creators. Their presence shapes the growth of galaxies. Their gravity helps form stars. Their quiet influence provides the framework for countless solar systems to find stability and rhythm. Even when they are not feeding, even when they are still, they are guiding. When you look up at the stars on a clear night, most of what you see is held in place by one of these central giants, not just ours, but others, scattered throughout the cosmos. Each one a hidden companion to the dance of stars, unseen but deeply felt. Some spin, quickly, Some drift alone. Some pull in gas clouds that spiral into glowing rings before they disappear. Others wait silently, as if resting between breaths. To imagine a supermassive black hole is to imagine a gravity so gentle and so complete that it shapes a galaxy without ever making a sound. It is not a force you would feel with your hands or hear with your ears. But it is there, holding the spiral together, like a lullaby played on strings of starlight, humming softly beneath the structure of everything we know. Falling into a black hole sounds like something fast and dramatic, as if you would be swept away in a sudden rush, spinning and tumbling through the dark. But in truth, it would feel much quieter than that. Almost still, almost calm. You would not fall in with a scream or a flash. You would drift, slowly and silently, past a point that cannot be undone. From far away, a person watching you fall would never quite see you cross the boundary. You would appear to slow down, becoming dimmer and redder, stretched and softened, until you faded into invisibility. It would seem as though time had stopped for you right at the edge. That last moment before crossing would stretch on forever in their eyes. You would become frozen, suspended on the brink, like a leaf caught in the air just before it touches the ground. But from your own point of view, time would feel normal. You would continue moving, passing through the event horizon without even a bump. There would be no line, no sound, no sign. You would just keep falling. The space around you would feel deeper, more curved. The light from the outside world would fade behind you, and ahead there would be only inward, no direction but down. Not down in space, but down in gravity. Inside the event horizon, all paths lead to the center. You cannot stop. You cannot turn around. Every moment carries you closer to the singularity, that place where gravity becomes infinite and space itself may no longer behave the way we expect. It is a journey not through space, but through the warping of space. A slide through a landscape shaped by mass so dense it folds the rules of motion into a single conclusion. And yet, there is a strange kind of peace in this idea. Once you pass that point, you are no longer being pulled. You are simply moving. There is no struggle, no resistance. You are following the natural lines of space-time. The same way a river flows toward the sea, you are flowing toward a place where time and space themselves come to rest. No one knows what happens at the singularity. It may not even be a place in the way we understand places. Our math breaks down there. Our models stop working. Some believe it is a doorway to another universe. Some think it is the end of everything that entered. But all agree on this much. Inside a black hole, the journey continues until it cannot continue any further. So falling in is not like being snatched away. It is more like being drawn into a dream that has no waking, a quiet motion into a place beyond knowing, a place where time stretches thin, where space curves softly inward, and where the fall itself becomes the last story you ever travel through. When we think of mirrors, we think of reflections, light bouncing back to us, carrying an image of whatever stands in front of it. Even in the darkest glass, there is a hint of shape, a glimmer, a ghost of what stands nearby. A black hole is like a mirror turned inside out. It reflects nothing. It does not scatter light back or give any hint of what has entered. It is a surface without a surface, an outline without a glow, not because it refuses to show, but because it cannot. Light that crosses the threshold is no longer free to return. It is drawn inward, absorbed into the curvature of space-time itself. Imagine standing far away, watching a star drift behind a black hole. As it passes, the light from the star does not vanish abruptly. It bends. It arcs around the hidden mass, creating strange rings and distortions, like ripples through glass. This bending is called gravitational lensing, and it is one of the few ways we can glimpse a black hole's presence. But the hole itself remains invisible, a dark core at the center of the bending. It is not a shadow in the normal sense. A shadow comes from something blocking light. This is a darkness born from light's path no longer leading outward. If you could drift closer, the darkness would deepen. The glow of gas and dust swirling outside the event horizon would frame it, a faint halo of motion, but at the center, nothing. No reflection of your own face, no echo of your own signal. Just an opening that swallows every attempt to see inside. It is the ultimate privacy. The universe's secret keeper. Not even information as we understand it seems to survive beyond that edge. This lack of reflection makes black holes seem final and absolute, but there is also something strangely gentle about it. They do not push light away. They do not hide behind walls. They simply bend space-time so completely that every path leads inward. They are not blank because they are empty. They are blank because they are full of something we cannot yet describe, so full that nothing else escapes. Thinking about a black hole as a mirror with no reflection can be comforting in its own way. It is a reminder that not every mystery reveals itself. Some things remain unknown, not out of malice, but out of the nature of what they are. In the same way a dream fades when you try to hold it, the inside of a black hole slips beyond our reach as soon as we try to picture it. All that remains for us is the edge, the bending of light, and the quiet certainty that something waits beyond, unseen but very real. The idea of a black hole swallowing the Earth sounds like something from a science fiction story. It paints a picture of a dark mouth racing through space, gobbling up planets and stars without warning. But the truth is far more comforting, and a little less dramatic. Black holes are not hunters. They do not chase or pounce. They sit quietly where they are, following the same rules as everything else in the universe. Gravity may be strong near them, but that strength has boundaries. If you replace the sun with a black hole of equal mass, the Earth would continue to orbit it just the same. The sky would grow dark, of course, and the warmth would vanish, but the shape of the orbit would remain. The black hole's pull would be no greater than the sun's, because gravity depends on mass, not mystery. It is only when you get close, very close, that the difference begins to matter. A black hole's grip grows tighter the nearer you drift, but from far away, it is no more dangerous than any other object of the same mass. So could a black hole eat the Earth? Only if one were to pass incredibly close. But space is vast. The nearest known black hole is thousands of light years away. And even if one wandered nearby, it would move slowly, its influence spreading like a soft tide, not a tidal wave. Planets would feel its pull long before anything dramatic occurred. There would be time to watch, time to understand, time to marvel. The Earth itself is safe not because black holes are weak, but because they are rare, and still, they do not leap through the cosmos. They drift, like stars do, following the quiet currents of gravity. A stellar black hole born from a supernova might nudge nearby space, but it does not lash out. It does not reach. It simply exists. Much of the fear around black holes comes from misunderstanding their nature. They are not voids that tear through the universe without purpose. They are dense, patient remnants of stars. They bend space, yes, but they do so calmly. Their power is real but not reckless. Thinking of them this way turns fear into curiosity. It replaces the image of a cosmic monster with that of a quiet presence. One that waits, one that holds, one that does not disturb unless disturbed. They are not here to take anything from us. They are content to be where they are, doing what gravity always does, holding things in place, shaping orbits, curving light, and reminding us how deep the universe can be. So no, the Earth is not likely to be eaten by a black hole. You are not in danger. The sky above you, even with all its strange and wonderful objects, remains a place of calm, a place to wonder, a place to dream. It is easy to imagine black holes as eternal. They seem so final, so absolute. Once something falls in, it does not come back. Their edges are clean, their pull is quiet, and their presence feels permanent. But even black holes do not last forever. Over long enough stretches of time, they begin to vanish. Not suddenly, not loudly. They fade in the softest way possible. Bit by bit, they evaporate. This idea was first explored by Stephen Hawking, who showed that black holes are not perfectly silent. They give off something, a faint radiation that seeps from the edges, not from the inside, but from the surrounding space. This happens because of the strange nature of empty space itself. At the smallest scales, space is not truly empty. It hums with tiny fluctuations, particles popping into existence and then vanishing, all within a blink. These pairs of particles usually cancel each other out, leaving no trace. But when they form near a black hole, one can fall in while the other escapes. The one that escapes becomes real. It carries away a tiny bit of energy. That energy has to come from somewhere, and it comes from the black hole itself. Slowly, over trillions of years, the black hole loses mass. It grows smaller. Its surface temperature rises. Its whisper grows louder. And eventually, after an unimaginable length of time, it fades away entirely. This evaporation is not fast. For the black holes formed from stars, the process takes far longer than the current age of the universe. The black hole at the center of the Milky Way will still be there long after the stars around it have burned out, but it will not last forever. One day, it too will shrink and vanish into the soft background of space. When the final moment arrives, the black hole does not explode. It does not roar. It ends in a quiet release, a final breath of radiation, and then nothing. No object, no shadow, not even a trace. Just space, stretched a little differently, remembering something that once was. This slow disappearance changes the way we think about black holes. They are not vaults that hold their contents forever. They are chapters in the life of the universe. Long ones, quiet ones, but still part of the story. They come into being, they shape the cosmos, and then they leave. There is something deeply gentle in the thought. These great and powerful objects, capable of pulling in stars and bending light, eventually give themselves back to the universe. Their end is not destruction, but return. A soft release of energy, like a candle that keeps glowing long after the flame has gone. In the end, black holes do not hold on forever. They let go. And in that letting go, they become part of everything once again. Long before anyone had seen a black hole, long before we could detect the ripples of their collisions or glimpse the glow of their edges, there was only the math. Quiet, precise, and stubbornly strange, it lived in chalk dust and notebooks, equations that whispered of things no one had ever observed, not guesses, but results. As if the universe itself had folded its secrets into the fabric of numbers, waiting for someone to read between the lines. In the early 1900s, Albert Einstein gave us general relativity, a new way to understand gravity. No longer was it just a force pulling on objects. It became the bending of space and time. Mass could curve space-time, and that curve would tell other objects how to move. It was a beautiful idea, rich with implications. But, almost immediately, the math began to offer something strange. a solution that described an object so dense, its gravity would pull inward endlessly. This solution came from Karl Schwarzschild, who found it while serving on the front lines of the First World War. He sent it to Einstein by mail. At first, no one believed it could describe anything real. It seemed like a flaw in the equations, a strange path that went nowhere, a mathematical ghost. But the math did not go away. It sat patiently in physics journals, waiting. Over the decades, others returned to it. They studied it from different angles, asked it new questions, and again it gave the same answer, that such objects could exist. That mass could collapse into a point, that space-time could fold inward so completely that nothing could leave. Eventually, astronomers began to notice things in the sky that seemed to match. Stars orbiting invisible companions, light curving where no star was seen, X-rays flaring from places where matter was being torn apart. The pieces began to fit. The math had been right all along. There is something quiet and awe-filled in that realization, that we can sit on this small planet, write down symbols with chalk or ink, and through those shapes, glimpse the architecture of the universe. Long before we had the tools to look, we had the tools to think. And thinking, slowly and carefully, had pointed to the truth. The black hole was not discovered by looking through a telescope. It was discovered by listening to the rules of nature, by following equations wherever they led, even into the strangest corners. What once seemed like an impossibility became an inevitability. The math predicted the impossible, and the universe, in its own time, confirmed it. So when you hear the term black hole, you're not just hearing about a distant object in space. You are hearing the echo of a line drawn in a notebook, the quiet answer to a question asked with numbers, the proof that, sometimes, the universe tells its secrets first through silence and symbols, before ever lighting up the sky. It is strange how names can lead us astray. We hear the words black hole and the mind immediately pictures a gap, a pit, a kind of hole in space where everything falls in and nothing comes out. But this image, though powerful, is not quite true. A black hole is not a hole at all. It is not empty. It is not hollow. It is not even open. It is something far more curious. A place, not an absence. A region where mass has been folded so tightly, the space around it cannot help but curve. If you could float nearby, it would not look like a hole in the road or a tunnel through space. You would not see an opening. You would see a shadow surrounded by light. A place where all the paths bend inward, where light cannot climb away. It is the surface, the event horizon that defines it, not a gap, but a boundary. Not a place to fall into from nowhere, but a region with weight and shape and presence. The mass of a black hole is real. It curves space not because it has made a hole, but because it has made a place so dense that nothing else can remain unchanged. The matter that once made up a star or a cluster of stars still exists, but it has been pressed down into a form that escapes our understanding. Some theories call it a singularity, a point with no size and infinite density. Others wonder if it is more complicated, wrapped in the rules of quantum physics we have not yet solved. But whatever it is not nothing. Calling it a hole makes it sound like a missing piece, but nothing is missing. It is all still there, just hidden behind a curtain we cannot lift. The space outside it still behaves according to gravity's rules. You could orbit it safely from a distance, the same way you orbit any massive object. You would feel its pull, but you would not be drawn in unless you crossed a line. The surface of the black hole is not solid, but its pull is absolute, not because it sucks, but because the direction of time itself leans inward. It helps to think of it as a place where geometry has changed, where straight lines bend so much they loop back, where time points inward instead of onward, where everything you know about motion and distance still applies, but in a way that turns quietly towards something you cannot reach. So the name is misleading, but not completely wrong. It captures the feeling of mystery, the sense that something has disappeared. But what has truly happened is that something has become so heavy, so concentrated, that space and time have wrapped themselves around it. Not a whole, but a presence. Not emptiness, but silence. Not absence, but something the universe has chosen to fold away. Time is one of those things we usually trust without question. It ticks forward. It moves in a line. We plan our days by it, measure our lives with it, and expect it to behave the same no matter where we are. But near a black hole, time forgets how to be ordinary. It stretches, it slows, it begins to curl at the edges, and in those curls, strange possibilities begin to appear. Among them is the quiet idea that black holes might allow for time travel. Not in the spinning, flashing, loud kind of way from stories, but in a slower, more elegant form. One that follows the rules, bends them slightly, and never breaks them completely. Black holes are places where time and space trade roles. Outside, space tells you where you are and time moves forward. Inside, space pulls you in and time turns inward too, and when that turning happens just right, you can loop. There are theoretical paths around certain types of black holes, called rotating black holes, that might allow you to circle through time. These paths are called closed, time-like curves. The name is heavy, but the idea is soft. You start somewhere, you travel a path, you come back to where you started, not just in space, but in time, a loop that returns to its beginning, a circle with a heartbeat. For this to work, the black hole would need to be spinning, fast, not just turning slowly like a planet, but twisting space around itself. As it spins, it drags the space near it into a whirlpool. This twisting is called frame dragging, and it means that nearby, you cannot stay still. Even if you hover, you are pulled around. And if you move just right, your path might bend so deeply through this twisted space that you arrive before you left. It sounds impossible, and maybe it is. These loops are fragile. Tiny disturbances could break them. A stray particle, a wisp of light might be enough to unravel the journey, and no one knows what happens at the center of a real black hole. The equations falter there. The math becomes shy, so perhaps these time paths exist only on paper, beautiful circular dreams drawn in chalk. But even if we never use a black hole to visit the past, the idea still stirs something gentle in the imagination. It suggests that the universe is more flexible than we thought. That time is not always a straight road, but sometimes a spiral, and somewhere, in the quiet spin of a black hole, that spiral might be waiting. Not every question has to lead to an answer. Some questions are like soft lights at the edge of sleep, glowing quietly as you drift. Black holes may not be time machines in the way we hope, but they remind us that time itself is not always what it seems. And sometimes, that's more than enough. Black holes are often imagined as lonely things, solitary, distant, drifting through the darkness like forgotten anchors, but they are not always alone. Sometimes they find each other. Sometimes they circle, not in silence but in a slow gravitational dance. Two invisible bodies locked in orbit, not by choice, but by the deep pull they each carry. It is one of the most powerful relationships in the universe, and one of the quietest. When two black holes orbit each other, they spiral, slowly at First, their orbits shrink with time. The energy of their motion does not simply disappear, it is carried away in the form of gravitational waves. These waves ripple outward through space, not as sound, not as light, but as subtle stretches in the shape of space itself. You would not feel them as they pass. They are so small that even the Earth's own movements drown them out. But with delicate instruments and patient watching, we have learned to notice. As the black holes spiral closer, the waves they send out become stronger. They grow in frequency and power. It is like listening to a deep drum beat that gets faster and faster. Then, in a final moment, the two black holes merge. They do not crash in a burst of light. They combine, smoothly and silently, into a single black hole larger than either one before it. The waves released in that final second ripple across the universe, traveling for millions or even billions of years before brushing past us, and we have felt them. In 2015, for the first time in history, we caught a whisper from this cosmic dance. Two black holes had merged over 1 billion light-years away, and their final embrace sent out a signal that crossed the galaxy. It reached Earth, stretching space by a distance smaller than a proton, but just enough for our instruments to catch. It was a quiet sound made by giants, and it changed everything. That event showed us that black holes are not just theoretical. They are real, they move, they collide, and when they do, they make waves. These waves are a new way of seeing the universe. Not with eyes or telescopes, but with the fabric of space itself. It is like learning to hear in a place where we have only ever seen. There are likely many black hole pairs still out there, spiraling slowly, sending out their long and steady rhythm. We cannot hear them all yet, but we are learning. And as we listen more closely, we may discover that the universe is far more connected than we ever thought. Black holes do not simply sit in silence. They find each other, they circle, they merge, and when they do, the entire cosmos feels their presence. Even in darkness, even in stillness, there is motion. And even in silence, there are stories being told. Black holes are known for pulling things in, for capturing light, for keeping their secrets sealed in gravity. But in some cases, they do something unexpected. Instead of only drawing matter inward, they also send it outward. Thin streams of energy, sharp and bright, are fired from their poles like arrows. These are called jets. And though they do not come from inside the black hole, they are shaped by it. They rise from the edge of the event horizon, where things spin and heat and twist faster than anywhere else in the universe. When matter falls toward a black hole, it does not always fall straight in. It forms a disk, a spinning, glowing, chaotic whirlpool of gas and dust that wraps around the black hole's waist. This disk, called an accretion disk, gets hotter as it spins. Particles collide, light bursts out, temperatures soar. The black hole's pull is strong, but not all the matter makes it across the line. Some of it is redirected. Some of it is caught in magnetic fields that twist through the spinning disk like threads in a storm. These fields take energy from the rotation, and with it, they launch streams of particles away from the black hole. These jets do not drift. They shoot. They travel near the speed of light. Long, narrow beams that stretch across galaxies. If you could see them with your eyes, they would look like glowing lines drawn across the dark. Not fire, but plasma. Not wind, but energy. They are among the most powerful structures in the cosmos, created not by explosion but by rotation and focus. It is a strange picture. A black hole, silent and invisible at the center, surrounded by a storm of light and heat, and topped by two beams of matter that reach out like cosmic lighthouses. They do not last forever. They fade when the accretion disk settles, when the black hole has nothing more to feed on. But while they last, They shine with fierce beauty. These jets tell us that black holes are not only endpoints, they are engines. Their spin matters. Their surroundings matter. They are not isolated but reactive. The space near them is alive with motion and change, and through that motion, they shape the galaxies around them. Many of the brightest objects in the sky are not stars, but the areas around supermassive black holes with jets. They are called quasars when they shine with incredible brightness. We can see them across the universe, acting as beacons from the earliest times. Their light took billions of years to reach us, and yet it comes from something rooted in darkness. In this way, black holes become artists. With gravity and spin, they sculpt these long, glowing lines that stretch through space. They do not speak, but they leave a mark. Not a trail of destruction, but a pattern of light that continues long after the source is quieted. It is often said that falling into a black hole would be the end, an instant collapse, a terrifying moment. But the truth is far quieter than that, especially if the black hole is large. In fact, if you were to fall into a supermassive black hole, you might not even feel the moment you cross the event horizon. There would be no lurch, no sudden darkness, no pain. Just the continued drift inward, as smooth as before. This is because the gravitational gradient across your body would be gentle. In a small black hole, the difference in pull between your head and your feet would be sharp, which is what leads to that stretching effect we talked about earlier. But in a larger black hole, this difference is much smaller. The stretching happens deeper in, so crossing the edge feels like nothing at all. A silent passage into a region where the paths of space all curve inward, but with no marker to show where the change occurred. Your body would continue to move forward. Light from the outside world would fade as it bent around behind you. You would begin to see strange things. Perhaps the entire sky would appear to fold into a glowing ring. Perhaps time would seem to slow in the outside universe, even while your own clock ticked along at its usual pace. But you would not feel lost. You would simply be moving through a space where direction has changed its meaning. There would be no ground to reach, no bottom to hit. Inside the event horizon, the singularity lies ahead, not in space, but in time. You do not fall toward it as you fall toward the floor. You move toward it as you move toward tomorrow. It is inevitable, but it does not rush. And what happens there, no one knows. Perhaps space collapses completely. Perhaps time loops. Perhaps something entirely new begins. But the journey is not filled with chaos. It is filled with calm. For the traveler, there is nothing unusual at first. Gravity pulls, but gently. The passage inward is guided by the geometry of the space, not by struggle. You would have no control over your path, but you would not feel torn. You would feel weightless, floating toward a future with no map. There is something surprisingly peaceful in that idea, that one of the most powerful and feared places in the universe can be entered without drama. That you would not be crushed in an instant or burned away, that you would simply go on following a curve drawn by gravity itself. So often, we imagine black holes as endings. But the entrance, at least, is quiet. It is not a scream, but a sigh. Not a fall, but a drift. Not a terror, but a surrender to the shape of space. And for a time, it might feel like nothing at all. For so long, black holes were just shadows in the imagination. Theories, numbers, whispered possibilities that danced at the edge of what we could see. We could measure their pull. We could observe the stars that curved and circled near them, but we had never truly seen one, not directly, not as an image. Then, in 2019, something changed. Something quiet but extraordinary. A photograph was taken. It was not a close-up. It was not crisp or full of detail, but it was real. The first image ever captured of a black hole, not the hole itself, but the glow that surrounded it. The black hole sits at the center of a galaxy called Messier 87. It is enormous, several billion times more massive than our Sunday, and yet, from Earth, it looks no larger than a pinprick. It took a planet-sized effort to see it. Telescopes across the globe joined forces, combining their views to create a single instrument, one wide enough to glimpse the unseeable. This project was called the Event Horizon Telescope. When the image was released, it looked like a soft ring, a circle of golden light surrounding a dark center, not sharp, not smooth, but filled with something powerful. The light comes from gas swirling around the black hole at incredible speeds. It shines before it disappears. Some of it bends around the black hole, curving in such a way that we can see what lies behind as though it were in front. That ring is not just light. It is light that has traveled along the deepest bends of space. And in the middle of that ring lies the shadow, the place where no light escapes, the mark of the event horizon, the thing we were told could never be seen. But there it was, not imagined, not drawn, not rendered, seen. A picture taken with radio waves stitched together with patience, math and global collaboration. A quiet triumph. Looking at it, people described it as many things. A glowing eye, a smoke ring, a soft hole burned into the sky, but more than anything, it felt like a glimpse of the invisible, a peek behind the curtain, a dream confirmed. It told us that black holes were not just part of the story, they were real and waiting. Since then, more images have followed, sharper, closer. We are beginning to learn how black holes spin, how they feed, how they shape the space around them. But that first picture still lingers, that glowing ring around a place where time folds inward. It reminds us that with patience and wonder, the universe reveals itself, not all at once, not in full, but enough. Sometimes, seeing just the outline of a mystery is enough to feel its presence. And sometimes, that presence is beautiful. A ring of light around silence, a photo of something that cannot shine, framed by everything it has touched. Most black holes form when a single star reaches the end of its life. It burns through its fuel, collapses under its own gravity, and vanishes into a point so dense that even light cannot escape. But that is not the only way a black hole can be born. Sometimes it takes a meeting, a merging, a quiet collision between stars that draws them together, not in fire, but in gravity's embrace. When two neutron stars collide, the result can be more than a burst of light. It can be a birth. Neutron stars are already dense, already near the edge of becoming black holes themselves. They are the cores left behind when massive stars explode. Imagine an entire sun compressed into a sphere the size of a city. Now imagine two of them spiraling together. Each orbit draws them closer, pulling them into a tighter and tighter dance. The energy of their motion radiates outward in waves that stretch space itself, and when they finally meet, they do not bounce. They blend. In that moment, space shakes, light flares, elements are forged. Gold, platinum, heavy things that do not come easily. It is not just destruction, it is creation. And as the glow fades, what remains may be a black hole, a new presence, born not from one life ending but from two lives joining. This kind of black hole is quieter than a supernova. It does not announce itself with a single spectacular blast, but it leaves behind ripples, gravitational waves that carry the memory of the collision across the universe. We have, have felt those waves. We have measured them, and in doing so, we have watched black holes being born in real time. There is something deeply gentle in that. That something as powerful as a black hole can come from a moment of coming together. That the meeting of two old stars can lead to the beginning of something new. It reminds us that gravity does not only pull things apart, it also brings things close. The black hole that forms is silent. It gives no sign of its newness. It does not carry scars or stories on its surface, but the space around it remembers. It echoes with the waves left behind. Those waves stretch through galaxies long after the light has faded, like the soft sound of footsteps after the person has gone. Every time we detect one of those ripples, we are hearing a birth, not of a child, not of a planet, but of a black hole. Formed by the slow pull of gravity, the spinning of ancient stars, and the quiet patience of time, it is a kind of cosmic lullaby, a reminder that even in the dark, things can come together. And from that closeness, something new can begin. It may sound strange to say that black holes help build galaxies. After all, they are known for taking things in, not giving things back. They swallow light, bend time, and hold on to whatever comes too close. But despite their quiet hunger, black holes are not destroyers. They are sculptors, architects, invisible centers that help shape the very structure of the universe. At the heart of almost every galaxy there is a black hole. Not a small one, but a supermassive one, with millions or even billions of times the mass of the Sunday. These giants sit calmly at the center, not flashing or roaring, just holding everything in place. Their gravity reaches out across light years. It does not pull everything in, but it keeps the stars moving in gentle orbits, spinning in beautiful spirals and ellipses. Without them, galaxies might not hold together. The stars could drift, the arms could unravel. The galaxy might never settle into the shapes we know, but their influence goes beyond just holding things steady. When a black hole grows, when it feeds on the matter around it, something surprising happens. The material that falls toward it heats up. It spins faster. It begins to glow with incredible energy. And some of that energy escapes. It pushes outward, not as light alone, but as wind, as pressure, as jets of particles. This outflow spreads into the galaxy, stirring the gas and dust that float between stars. It compresses some clouds and scatters others. In doing so, it helps shape where new stars will form and where they will not. This balance between feeding and pushing is delicate. If the black hole eats too much, it can blow away the gas that stars need to form. If it eats too little, the galaxy may not get stirred enough to spark new creation. But somehow, across billions of years, this quiet rhythm seems to hold. Galaxies grow, stars are born, and at the center, the black hole waits. Some galaxies shine bright with new stars. Others have gone quiet, their starlight fading as their gas thins. In both cases, the black hole has played a role, not as a villain, but as a partner in the story. It helps decide how fast the galaxy grows, how it changes shape, and what kind of stars it can raise. To think of black holes this way is to let go of fear. They are not only places where things end, they are also part of how things begin. Their silence does not mean emptiness. Their pull does not mean destruction. They are woven into the process of becoming. They are part of the galaxy's memory and part of its future. Even in the stillness of space, even in the dark corners where light cannot escape, there is a presence shaping everything, gently, patiently, holding the stars in place while the universe continues to unfold around them. Stephen Hawking spent much of his life thinking about black holes. He did not simply study their mass or motion. He asked deeper questions. What happens to information inside a black hole? Do they truly erase the past? Do they last forever? His work took him to the edge of what science could explain, where math becomes quiet and strange. And in that space between certainty and curiosity, he left us with something beautiful. Before Hawking, black holes were seen as eternal. Once formed, they were thought to last forever, swallowing everything and giving nothing back. But Hawking showed that even the darkest objects might not be completely silent. He discovered that black holes could slowly leak energy through a process now called Hawking radiation. The idea was bold. It came from blending the rules of quantum physics with those of gravity, two systems that normally speak different languages. Hawking radiation is quiet. It comes not from inside the black hole, but from just outside it, from the strange dance of particle pairs that form in the vacuum of space. Sometimes, near the edge of a black hole, one particle falls in while the other escapes. The escaping particle carries energy away. Over time, this causes the black hole to shrink, slowly, softly, like a candle burning without a flame. This was a profound idea. It meant black holes do not last forever. They fade, they vanish, not in a flash, but in a whisper. Even something that swallows light can eventually grow dim. Hawking's insight changed the way we think about the universe. It made black holes seem less like perfect ends and more like part of an ongoing story. They have a beginning, a middle, and yes, an end. But perhaps the most touching part of Hawking's work is not just the science itself, but the spirit in which he shared it. He believed that knowledge should be accessible, that the mysteries of the cosmos could be explained gently, without rushing. He had a gift for turning complex ideas into questions anyone could sit with, like stargazing with your mind. Toward the end of his life, he wrote about black holes with a kind of affection. He called them not prisons, but puzzles, not voids, but windows into something deeper. And through his work, black holes became less frightening, more human. They stopped being only symbols of loss and started to feel like places of wonder. So in the long, slow glow of Hawking radiation, there is something more than science. There is grace. There is the sense that even the most powerful things in the universe can soften, that even the dark can give something back. And as we continue to explore the cosmos, we carry his questions with us, quietly, curiously, like a final whisper from a mind that looked into the dark and found something luminous there. Sometimes the universe presents ideas that sound more like stories than science. They arrive with a quiet question, not to be answered right away, but to be held and turned slowly like a smooth stone in the hand. One of these questions is simple, yet enormous. What if our entire universe is inside a black hole? It is not a theory that shouts. It does not promise proof, but it lingers, it waits. And the more we look at how black holes work, the more that question seems worth asking. A black hole forms when enough mass is packed tightly into a small space. Its gravity becomes so strong that space folds inward and light cannot escape. But from the outside, that fold looks like a closed surface, a boundary. And inside that boundary, time and space behave differently. Some physicists began to wonder, what does it look like from the inside? Not the inside of the star that formed it, but the space beyond the event horizon. Could that region have its own dimensions, its own direction of time, its own stretch of space-time that unfolds the way our universe does? This idea leads to something both wild and quiet, that a black hole may not end in a point. It may instead bloom inward into its own space. A new space, one that looks, from the inside, like an expanding universe, like the one we live in now. From our point of view, our universe is growing, galaxies are drifting apart, time moves forward, space stretches. And at the very beginning there was a moment when everything was pressed together, dense, hot, small, much like what might happen at the heart of a black hole. If our universe is inside a black hole, then everything we see is part of that hidden interior. The stars, the dust, the thoughts you are thinking right now. It would not feel any different. There would be no edge, no curve to tell us we are inside something else. Only a sense that space is expanding and that time is unfolding, moment by moment. This theory, sometimes called the black hole cosmology model, does not claim to be the final word. It is one way to look at a very old question, but it offers a soft kind of poetry, that perhaps creation is not a single spark but a pattern, that what collapses in one space might open in another, that every black hole could be a seed, and that our own universe began as one of those seeds long ago. There is no proof yet, only hints, only math and imagination walking slowly side by side, but it is enough to make the stars feel closer, to imagine that what surrounds us is not just vast, but also sheltered, held quietly within something greater, like a dream inside another dream, folded with care. Black holes are often thought of as silent, places where things go in and never come back, cold, dark and final. But silence is not the same as stillness. And just because a black hole says nothing, that does not mean it remembers nothing. There are theories, supported by new observations and quiet equations, that suggest black holes may hum with the echoes of everything that has ever fallen into them. Not as sound, not in the way our ears would hear, but as ripples, as vibrations, as shape. When matter falls into a black hole, especially in large amounts or with great speed, it does not vanish without a trace. It collides, it stirs the space around it, and it sends out waves. These are gravitational waves, gentle shivers in space-time that travel outward, carrying information about what just happened. They are like the final notes of a song played on a cosmic drum, fading as they stretch through the dark. The surface of the black hole, or more precisely, its event horizon, may also ring. Theoretical models suggest that after something falls in, the black hole settles, it adjusts, and during that settling, it may vibrate, just a little. These vibrations have been compared to the ringing of a bell, a soundless bell, ringing in space and time instead of air. These waves carry the signature of what fell in, how massive it was, how fast it moved, what direction it came from. Physicists call this the black hole's quasi-normal modes. The word is technical, but the image is simple. A star falls in, and the black hole replies with a hum, not forever, just long enough to say, "I noticed." The sound of a falling star, not heard but felt. These echoes do not last long. They fade, and the black hole becomes still again, but in that fading we can listen. With our gravitational wave detectors, we are beginning to pick up these final songs. They are faint and far, but they tell us stories. Each one is a quiet record of a moment in the universe when something changed. This idea gives black holes a kind of memory. Not a memory that can be read or written down, but one that leaves marks in the structure of space itself. It is not about recording facts, it is about resonance, a rhythm in the dark, a response. So perhaps black holes are not just places where things end. Perhaps they are instruments. Perhaps they resonate with the things they receive. They may not share what they hold, but they do respond. They echo, they ripple, and for a brief time, they sing. Even in silence, even in darkness, there are vibrations. The universe remembers in waves. And black holes, though they seem like the quietest places of all, are no exception. They are not empty. They are full of sound, waiting to be understood. And so, as you settle deeper into sleep, remember this. Even the darkest things in the universe can shimmer with quiet beauty. Black holes aren't the end. They're doorways, mysteries, heavy with silence and secrets. They don't roar, they hum. And maybe, just maybe, they dream too. Thank you for drifting with me tonight. Sleep well, and may your dreams be full of stars that fall gently, galaxies that twirl slowly, and questions that don't need answers, only wonder.